here's level 2. In level 2, I notice, wait a second, I don't have a negative and a positive of the same number, right? This is not 5x and negative 5x. This is not y and negative y. How is anything going to eliminate here? And so the reason that this is level 2, and it's a little harder, is because there's an extra step at the beginning, right? There isn't something that's going to eliminate here. So I have to make it so that there is. So what I do is I look and I say, okay, well, let's see. This is a 2y. If this was a negative 2y, then it would cancel with this positive 2y. So how can I make this a negative 2y? Well, what I can do is I can multiply this whole equation by negative 2. Because then when I distribute, right, this negative 2 will multiply by this y, and it'll make it a negative 2y. And I'm allowed to do that, right? Just like I can distribute with an expression, or I can add with numbers, I can distribute in an equation, and I can add with equations. So this whole equation is going to change. So let's do this. And I'm going to distribute. Now you got to be careful. This is a negative 2. So negative times a positive is a negative. 2 times 5 is 10. This is a positive 1. Negative 2 times positive 1 is negative 2y, right? Which is exactly what I want. And negative 2 times 15 is negative 30. Now, this equation, I don't need to change this equation, right? Because I just changed this top one. This negative 2 is going to cancel with this positive 2. So I'm just going to recopy this equation beneath so I can see it. And then I'm ready to add them, right? Because when I add them, this is going to cancel, which is what I need. So negative 10 plus 3 is negative 7. Negative 30 plus 9 is negative 21. I'm going to divide by negative 7. Negative x equals a negative divided by negative is a positive. So I have my x value, and I still just need my y value. So I'm going to go and plug in. I'm going to plug in my x. I can plug it into this equation, or even to this equation. Once I create this equation, that equation is what's called equivalent to this one, and they're the same. So if I want to plug in that 3 to this one, I can. I'm going to just find what I think is the easiest one, right? Which is like this one. It's got small positive numbers, right? It's always a good thing. So I'm going to plug in the x to that one. Three times 3 is 9. When I subtract 9 from both sides, I end up with 2y equals 0. And I know when I divide by 2 on both sides, right, 0 divided by 2 is just going to be 0. So my y value is 0. Next example. In this one, what I could do is I could say, oh, well, this positive 4 will cancel with a negative 4, and I could multiply by negative 2, kind of like I did in the first one. But even easier that kind of jumps out to me is this is a positive and a negative of the same number. So what if I just multiply one of these equations by negative 1? Right? Wouldn't that be easier? If I just multiply this by negative 1, this will be a negative 3. And that'll be positive 3. That'll work. Or I can multiply the top one by negative 1, and then this will be negative 3, and that'll be positive 3. So it actually doesn't matter. I can multiply either the top or the bottom by negative 1. Either way, my result will be the same. So let's go ahead and multiply the top by negative 1. And I could have chosen the bottom, and if you want a little challenge, you can choose the bottom. The reason I chose the top is because it's negative 13 over here. When I multiply it by negative 1, it's going to become positive. I like positive numbers, so that's why I chose this one. So negative 1 times 3x is negative 3x. Negative 1 times 2y is negative 2y. And negative 1 times negative 13, don't forget that last step, right? It's the whole equation that gets multiplied, is positive 13. And then this one, I don't need to do anything to this equation. I'm just going to recopy it because look, now I have a negative 3x. And I'm going to just copy that positive 3x. So this will cancel. Negative 2 plus 4 is 2. 13 plus 1 is 14. 2, and y equals 7. So halfway there, I have my y value, and I need my x value. So I'm going to go ahead and just plug in. I can plug into this equation, this equation, this equation. I'll just plug into this one. So I have 3x plus 4 times 7 equals 1. 4 times 7 is 28. 3x equals 1 minus 28 is negative 27. And I divide by 3, and I get x equals negative 9. Okay, on the next one, I printed mine with an error, but yours should be correct on your copy. So this says x plus y equals 8, and 850 plus 7y equals 6050. Now, this should look familiar to you, hopefully, because this is what we talked about last Friday, right? There was Smarties and Dum-Dums, and the number of bags of Dum-Dums and the number of bags of Smarties added up to 8, right? And then the Dum-Dums were $8.50 a bag, and the Smarties were $7 a bag, and Miss Glass spent a total of $60.50 on them. So this is the kind of system that we might end up with in a problem like that. So right now, we're not talking about Smarties and Dum-Dums, we're just talking about x and y. But how would I solve a system like this? Well, in order to get one of these to cancel, right, if this was just a negative 850, or if this was a negative 7, then this would cancel just like any other system that would cancel with elimination, right? So it's this top equation that I'm going to multiply, and I can multiply it by either negative 850 or negative 7. Either will work. I'm going to multiply by negative 850. I'm going to multiply by negative 7 instead? That's fine. So that becomes negative 850 times x is negative 850x. Negative 850 times y is negative 850y. And negative 850 times 8, you could do this in your head, right? You could do 8 times 8, and then you could do 0.5 times 8, and you could figure it out. But you can also, this is a really good time to use your calculator, and please don't hesitate to just use it to make this easier. Okay, so I'll do it in my head. Negative 850 times 8 is negative 68, right? And just be careful you catch the negatives, right? Each of these is a negative times a positive, and so all of the terms are going to be negative. Then I'm going to copy this over here. This is positive 850 plus 7y equals 6050, right? Now, what I'm noticing is maybe I should have multiplied by 7 instead of 850, because now I'm going to end up with a bunch of decimals. But it doesn't matter because I'm just going to use my calculator, right? So it's not, there's no stress involved in decimals because I can just use the resources that I have. This is a negative and a positive, the same number, it cancels. Negative 850 plus 7 is negative 150. And negative 68 plus 6050, right? These are different signs, so I'm going to subtract them and keep the sign of the larger number. So the large number is 68, so it's going to be negative. And when I subtract, I get 750. Okay? Oh, and I forgot the y here. Oops. So this is 150y. Now to get y by itself, we need to divide by negative 150. Divide by negative 150. So I get y equals, this is a negative by negative, so it's going to be positive. And 750 divided by 150 is 5. Okay, so I have my y value, which is 5. Now I need to plug this back in to one of these equations. Now in this case, there's a logical equation to plug this into, right? Both will work, both will get you the same answer, but this one is obviously way easier. So use that one. X plus 5 equals 8, right? I'm just plugging in for y here. So this is just a one-step equation, and I'm done. And if you remember, we got, when we solved the problem, right, that it was 3 bags of something and 5 bags of something, and this is the version of it that doesn't have any Smarties or Dum-Dums. We'll get there though.